So square root of 361. And we got a calculator, 19?
It's 19.
It is 19. 19. Just hit the button on your calculator. Everybody good with that? Got your, want to have a calculator for the next exam? Going to need it. Square root of 361 is 19. All is well for the first one, if you have a calculator. All right, what do y'all think? Square root of negative 16?
Not a real number.
Good, good. Yeah, why is it not a real number? Yeah, because the negative's in there. Why can't you have a negative in there? Because it's what?
Square root is 1 positive, 1 negative.
Yeah, right, because what does square root ask? Square root of the regular 16, you know, is 4. And it's 4 because 4 times 4 is 16, huh? So what number, so really square root is asking, what number times itself is negative 16? Well, nothing, right? You can't have a number times itself come out negative, can you? Right? You can't put a negative inside of a root. Why? Because if you did negative 4 times negative 4, that'd be positive 16. And you might say, yeah, we'll do 1 negative, 1 positive. Well, then that's not the same number times itself. That's times the opposite. That's not what square root asks for. Square root says what times its very self, not what times its opposite. So the very question of square root is what times itself, and there's nothing times itself that can ever be negative. So the square root of a negative number is always not real, isn't it? Your calculator will say error. All right, this is just hit the buttons on the calculator. Can you all do that? I think it's a valuable exercise. You have calculators with you? So I'll tell you the answer ahead of time. It should be, I mean, I don't know the answer, but it should be like 1.7 or 8 or something rough. What is it? 1.750? 1.750? That's good enough. They say thousandth place, rounded. Now, thousand has 3 zeros in it, right? So when they say thousandth place, they mean 3 places to the right. So that would be right there. Remember how rounding works? You go where they're saying round to the thousandth. 1,000 has 3 zeros. That means 3 places to the right. And you circle the 3 places to the right, and you look 1 to the right. Remember how rounding always works? Circle the place they want you to stop, and they want me to stop in the thousands. 3 zeros, 3 places. So look 1 to the right of that. If it's 5 or more, go up, huh? So 1.751 is the answer they want. That good? Yeah, we'll get that in your calculator. Have any trouble with the calculator? Grab me after. Just take a second.
The radicand.
Yeah, it's just...
Why?
Well, they're saying identify the radicand.
What the hell is...
Yeah, I mean, I agree with you, really. I mean, it's so dumb. It's so useless. It's that thing.
Really?
Yeah, that's like saying, where's Waldo? There he is.
Oh.
That,
Sometimes it's hard to find Waldo.
yeah, it's more interesting than this. It's just the thing in the radical. I should cut this out of the homework assignment. I don't know why I leave it in there. But anyway, I can't change it once it's been worked on. It's just the thing in the root. And I'm not going to put that on the test. So you can just forget about it. So, yeah, you actually will like it, huh? I just think, what's that going to do for your life? Later you can say, I know what the radicand is. Do you? I mean, that's really dumb, right? That doesn't teach you logic, doesn't teach you anything.
Because you're a radicand.
So there it is. So it's just dumb. There won't be any. No, that's it. Did you get it? Oh. All right. So f of t equals square root of t squared plus 1. Okay, there's the function they're giving me. Now, are you comfortable with function notation?
No.
Do you realize the parentheses? I'm always talking about functions in pre-calculus and pre-calculus a lot. Pre-calc. Anyway. I always call it a toaster in pre-calculus because I'm trying to help the pre-calc students get straight that a function is something you plug stuff into and stuff comes out. So a toaster is technically a function. You put in bread, get out toast. Put in frozen waffles, get out toasted waffles. Microwave's a function. Put in cold stuff, get out hot stuff, right? So it's a function is something you put stuff into, it does something to it, and you get stuff out. Well, that's what this is. And the notation with the t thing, it just means that's where it slides down. It would make no difference if they changed that x to be, that t, to be an x, or a y, or a z, or called it Joe. It's just a name, or made it blank. This is what I really wish they had done. I'm not in charge of math notation. But if it was my way, I would say just put a blank there. because that's all that letter is doing in a function. It just means whatever you plug into this toaster, they want me to put in a 0 here. They're asking me to put a 0 into the toaster, and then they're going to ask me to put in a -8, then they're going to ask me to put in a +8. So whatever you put into this toaster, it just slides down, it just goes right to there. That's all that means. That's all that letter means in a function. In fact, we even call it a dummy variable, because it's not doing anything important. It's a dummy.
Okay.
It's just holding a spot. That's all it's doing.
So if you put a 0 in, a 1 comes out?
Let's see why. So if you put in a 0, everybody good so far, that 0 just slid right to there. So what this notation means, this means put 0 into the F machine, or the F function. Like putting bread into the toaster. That's what this says. 0 has been put into the F machine.
Okay.
So you know what they're saying. And so you put it in. Here's the guts of the toaster. Now we're going to work out what happens. What happens? 0 squared, 0 times 0?
Is
0. Plus 1 is just 1. What's the square root of 1?
1.
Out comes a 1. This is what comes out of the toaster. You don't need to write out, but I mean, I'm just saying that's why the answer is 1. So when this over here says f of 0 equals 1, that's saying when you put in 0 to the toaster, or the f function, you get out a 1. That's what it's saying. Plug in, get out. If you're going to go on in math, it's huge. They use it all the time. Everything's a function. Okay, so then let's try the second part. They're saying, okay, now put a -8 into that toaster, into that function. Okay, so come back up here to the diagram. All right, I'm going to put -8 in the toaster, which means it'll slide right there. Right, anything you put in the toaster just slides right there. Now, don't be confused. You might think, well, you said you can't put a negative in. If there's nothing else, if it's just that number, then yeah, you can't do that. But we have other stuff here. This is going to be acceptable because that -8 is going to be squared right away, right? It's going to be the square root of -8 squared plus 1, which means it's going to be the square. What's -8 squared? -8 times -8? Positive 64 plus 1, which is 65. You just stop. They don't want the decimal. They just want you to stop right there. That's the answer, square root of 65. They don't want the decimal. They say use a radical. It's called a radical. Use a radical as needed. Right. Is that good? Does that make sense how functions work? You just plug stuff in, do whatever to it. So then how about +8? How about if we put in +8? Exactly the same, huh? Square root of 65 again.
The 65s need the square root because there is no true root.
Yeah, well said. You can't root 65. So the root says, yeah, I'm glad you brought that up, Kara. Yeah, if the number's rootable, like if they gave me something like root 64, you would do the root and he vanishes. It'd be just 8, no more root. Yeah, so if the root can do his root thing, he does it and he leaves. Like the repairman fixes the whatever and he takes off, right? But if the root can't root, it just stays there. I don't know what the comparison is there. The repairman just stays at your house. I don't know. He can't fix the fridge. He's moving in. I don't know. That doesn't really work. My analogy breaks down.
A contractor who can't finish the work on the house, he just sets up shop at your house and then he leaves.
Yeah, I don't think I'd want that. But anyway, so if the root can't root, it stays. We good? So there we go. Let's see. So they give me a little formula here. Oops, right here. R equals 2 square root 5L. And on word problems, you don't really need to read all the words. You just got to identify what the letters mean. It says right here, L is the length of the skid mark, and R is the speed. So R stands for rate or speed, and L is length of the skid. So basically, with this little formula, they can take the length of a skid mark. They can plug in the L and they can figure out how fast the car was going. So let's give it a try. So on part A, they say if they find a 220-foot long skid mark, How fast was that car going? So what do you do with that 220? Just plug it in for L. It's the length. Just plug it in. 2 square root of 5 times 220, right? Because it's 5 times L, right? Right next to the L. So 5 times 220. We good? So that's 2 square root of, it's 1,100. Is that what it is? What kind of answer do they want? They want decimal. Yeah, nice. So they just want you to hit the buttons on the calculator. See right here? You can always look at the blue line. You can tell what they want. They say decimal. Round to the 10th. So you guys have a calculator? Can you hit the buttons for me? 2 times square root of 1,100. I really have no idea what it is. I am not. Nobody got an answer? Did you get an answer? 66 point what? Can you give me one more? 3. So yeah, round. They want me to round to the tenths. 10 has 101 place. Look to the right. 66.3 miles per hour. That must have been a car. Must have been going 66 miles an hour. If the length of the skid was whatever it was, 220 feet. We good there? Makes sense. You use that little formula.
Sorry, one word.
Car.
L equals length what? Of skid.
Oh, length of skid.
Skid, okay.
That's all I'm going to say. The easiest way. So we have f of x equals minus 3 square root of x. Have I said before f of x function values are y? They're the same as y? Okay, good. Yeah, so then just do that. You know, anytime they give you a function, f of x, g of x, h of x, whatever, that's just y. That's by common agreement, math science world. They said those will just be y. So, okay, so this says y equals negative 3 square root x. Which of those 4 graphs is a right picture? Well, just make a table. I don't have anything fancy to suggest here. Bless you. Just make a simple little table. And by simple, I mean put in the easiest numbers you know. What's the easiest number you know?
0.
Me too, 0. And what's the next easiest number you know? 1. Yeah, just put those in. That's probably enough right there. Just put in 0, put in 1, put in to what? Well, for the x in the function. It's y equals minus 3 square root of x, so this will be minus 3 square root of 0. Now, what's the square root of 0? What times itself is 0? Yeah, 0, and 3 times 0 is just 0, so this is just 0. Okay, let's do the next one. Minus 3 times the square root of 1. What's the square root of 1? 1. Minus 3 times 1 is minus 3. Okay with those two values so far? See how I just plugged in the 0, plugged in the 1 for x. So let's make a little graph now. Let's put those points on the graph. So 0, 0, that's the origin. And then, remember, it's over and then down. So it's over 1, down 3, like that. So which one of those graphs goes down to the right? Yeah, A does. He's the only one that goes down, huh? To the right, down to the right. That's all we need. A couple dots, you got it. Is that too fast? Is that good? So on these graph ones, just make a little XY table. Just plug in the 2 easiest numbers, 0 and 1 for x. Plug them into the function. Get your 2 dots. Put your 2 dots, and you'll be able to tell which graph is the right one. Sometimes you might need to do a couple more dots if they're being more tricky, but usually 2 dots takes care of it. Is that okay? Keep moving. So y equals square root, that's just y on the left side. So go ahead, give that one a try. Make a little table, a little XY table. Plug in. If things aren't working out, you might need to plug in more numbers. You will on this one. So give this one a try. This one will be helpful. You'll learn some lessons about plugging in groups. So plug in 0, we'll plug it into square root of x minus 4. So plug in 0, you get 0 minus 4, which is the square root of negative 4. What's the square root of negative 4? Yeah, it's air. I'm just going to say no. It's not a real number, huh? Plug in 1. Square root of negative 3. Another no. Plug in 2. Square root of 2 minus 4. Square root of negative 2. Another no. Plug in 3. Square root of 3 minus 4. Square root of negative 1. No. Just keep going. Get a bunch of no's. Plug in 4. Square root of 4 minus 4. Square root of 0? 0. There's our first value. Over 4, up 0. The rest are no, 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 no. I'm going to actually write no, 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 no on my graph because that does help me to eliminate options. Which one of the graphs doesn't exist between 0 and 4? I don't know. It's hard to tell. They're all so tiny. But then, and now if we keep going to the right further, if you plug in like 5, square root of 1 is 1. So over 5, up 1, it's up here. So which one of the graphs exists only way over to the right? It's A again. See that? It's the only graph that begins way over to the right. It's a little hard to tell. On the A graph, you see they're going by 4s to 5s. Is that what they are? 5. So this is 5, 10, 15, 20. See what they're doing with the marks. Making sense? Are we good? Are we happy? That okay? So I just kept, whenever you have negative in a root, remember that's a no. It can't do that, which means the graph doesn't go there. That's what the graph is saying. I don't go there. Over 0, I don't do that. Over 1, I don't do that. 2, 3, I don't do that. I start at 4, and I go to the right. So that's graph A. We good? That feel like you could do that on a test in a week or so? Or soon?
The next one is
All right. Okay, so number 9. We got y equals the square root of 8x minus 2. Same thing, make a table. XY table. Start with 0, do 1. Plug in. You're going to need your calculator probably. Because they're going to be ugly decimals. You need some decimal values. Eight times 0 minus 2. That's square root of negative 2. That's a no, huh? But the next one's a yes. Square root of 6. You got to do that in your calculator. I don't know what that is. 2.4. So I'll just say 2.4. So that might be enough right there. Which of these is 0, no, and over 1 up like about 2.5? I don't know. It's kind of hard to tell, isn't it? I can't tell. Did I do that right? Square root of 6? Oh, I see the problem. It's confusing me. Yeah, it is C. See how it's C? It's over here to the right. At 0 doesn't exist right at 0. I believe it's C. Because, yeah, it is C. See how C is going up to the right? Now you might say, well, so's D. Yeah, but see how, I don't know if you can see it way in the back. You can blow these up when you're doing your homework. But D crosses the line here. See, what it's going to do is it's not going to exist at 0. But it does exist a little to the right of 0. I don't know how much. I mean, we don't have time to figure all that out. But it exists a little bit to the right of 0. But it certainly doesn't hit 0. We know that. We got a no-go at 0, right? So it ain't D. D actually hits the middle line. So does A. See how A and D are hitting the middle line? We know that doesn't happen. You guys tracking with me? A and D don't, and B goes left. That ain't right. So the answer is C. It is C. All right. I better leave that behind.